No te la noto. Probando, 1, 2, 3. Ay, perdón. Perdón.
Sí, hola. Sí. Ah, bueno, muchas gracias. Muchas gracias. Muy amable, muchas. Dígale lo mismo. Sí, muchas gracias. ¿Qué tal? ¿Bien? ¿Va chapa? ¿Va de conde caro? Orero José, imagina porque bombiriro Juan, no vale la pena. Y que tú vas de apula y no era pu. Oye, gente pona, oye, gente pona, vio. Oye, gente pona. ¿Va chapa? Va chapa, joa, gente. Va chapa. Estoy saludando en guaraní. Estoy diciendo hola, ¿qué tal en guaraní? No, ustedes tienen que decir va chapa y poná, tienen que decir. ¿Va chapa? Perfecto, ya saben. ¿Qué tal? ¿Bien? Hola, bueno, seguimos aprendiendo guaraní. Las cosas básicas. Te quiero mucho significa rojalhu. Rojalhu. No es jaihu, jalhu. Es una i gutural. Entonces, rojalhu. En el guaraní la i griega es no i. Por eso ustedes pronuncian más ibicuí, es ibicuí. Y también ibirapitá es ibirapitá. ¿Escuchamos? Ibirapitá. ¿Sí? Que en guaraní sí.
Ey, ey, hola, 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 hola. Hola. Hola, 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 hola. Hola, hola, hola. Hola, hola. Hola, hola, hola. Hola, hola. Hola. Hola, hola. Hola, hola. Hola, hola. Oh, hola, hola. Hola. Hola, hola. Hola, hola. Hola. Oh, oh, oh. Hola, hola. Oh, oh.
afternoon, how are you? It's a great pleasure to welcome you to this last part of the 28th GeneXus Encuentro that once again has brought together the whole community and celebrates it. I would like to thank the sponsors that are with us every year. During these 3 days, you have attended, you have been part of hundreds of stories, speeches, presentations, very inspiring one where it has been made clear once again that you have the power of doing in this GeneXus community. Next, we will have a very interesting keynote, maybe in your industry, in your sector, the sector that brings us together. You don't associate music to technology, but without any doubt, music has a lot to bring to us. So without further ado, I'm going to invite Fabio Hernán Chávez Moral, who is the director of the Orchestra of Recycled Instrument of Cateura from Paraguay.
Buenas tardes, ¿qué tal? ¿Cómo?
Good afternoon, how are you? So again, how are you? So I'm saying hello to you in Guarani. Echapan means how are you? And if you reply Ipora, that means very well. So you've learned something of Guarani. You know that in Paraguay, we speak two languages, Spanish and the native language, the indigenous language, Guarani, that is very much incorporated in our daily life. I believe that Paraguay is the only country where most of the people speak an indigenous language, even if they don't belong to that indigenous ethnic group. And in Paraguay, there is also an initiative, and that is why we have been brought together to this event. And it was born in a dumpster, one of the or a landfill, one of the biggest in Paraguay, called Cateura. It's the Cateura landfill that I'm showing here, a typical image of Cateura, the children who are looking for different things in the garbage, among the garbage. And actually, there are houses and things that have been built over the landfill. And this is not the result of what the community did. It's a result of what was not done in the city, which is to classify waste and residues. It would seem that the important thing in our societies is to have. And therefore, I was very happy to be invited to an event that is defending the value of doing, because doing, I believe, is what we have to have in our planet. We have to change that, because having things is what has led us to be in the current situation in our world, enormous inequality and huge sectors of the population who feel excluded from progress that is praised everywhere. So we decided that we would base our activities not on having but on doing. And there is a sentence that said not having anything is not an excuse for not doing anything. And when I started teaching music in this landfill, I did it as an environmental expert who had some additional time or some free time to teach music to the children of the people who were recycling with whom I was working. And the point of departure was this image, seeing children that had no alternative for their future. So I said, instead of working as an expert, I will work on doing music, which is what I could do. So on the basis of what I knew what to do, this is what I did and what I can offer. This is a very sad scene. What can you do here? And these are the options that the children and the animals have in the community. Our point of departure was, what do we have in order to do something? And what we had was what the world was sending us every day, garbage and waste. And what did we do? We started to making musical instruments using that same waste the people were throwing our way every day. So we started teaching music, and this is the center where solid wastes are received. We were on the street, but we also had something fundamental, a skill, a knowledge that the community already had, the reuse of the materials that the landfill was receiving in order to fulfill their needs. So when music became a need, we used those same materials to build the first instruments. And here we see a violin that has been built with a fork and a can, and this is the process through which we rescue the waste and we build an instrument that then we put in the hands of a child. This is the cello, and these are the part of the cello. And it's an oil can, but the brand of the oil brand is not sponsoring the orchestra. And this is a saxo that has all of the part, but it has been made with recycled material. This is how it was built. These are the parts, and the string instruments are built by Winston, or Wee Wee, as we call him. And the wind instruments are built by the father of Gideon Victor. So we are based on doing and not having. This guitar has also been made with recycled material, and this is a drum, and it's using X-rays materials. And let me tell you that it has a spectacular sound for candombe, a kind of music. And you can use any X-ray depending on the motto of the presentation. When we played with Metallica, this is the drum we made, and when we went to Parliament, that's the one we made. You will realize that politicians are not our best friends. Once they wanted to honor us with a title, and we said, we don't want to represent politicians because they represent going back or being backward. And we want to show them that doing without having anything, you can really live with dignity. This is a trumpet, this is our music school, the children with the violins, and The other one, it's her when she was younger, the one I'm pointing to. And this is a violin, more in detail, a little girl with a guitar, and they look so happy, as if it were the best instruments they could ever have, with a lot of work. And with these instruments we have composed a group that has been playing in many places, in Rio de Janeiro, then Panama, then Bogota, Argentina, in Ramallah, Palestine, and in Jordan, and in Denver, Colorado, with the Megadeth group, and this was in Phoenix, Arizona, also Toronto, Stanford. This was in Washington, D.C., the other one from Washington too, this one in Norway, in Oslo, which is the cleanest city in the world. You could not possibly imagine a place that's on the opposite spectrum of Cateura, and this was in Germany, and these are the places I really cannot pronounce it. Tokyo, and it says the recycled instruments of orchestra of Cateura, in Spain with King Sophie, Amsterdam, and this is when we went on a tour with Metallica, 50,000 people, with Stevie Wonder, you know him. Metallica again on a tour, and we also built an electrical guitar. All of our instruments are acoustic, and they don't need to be plugged in order to sound, but since we are going to tour with Metallica, we had to build an electrical guitar. And I don't know whether the meat in Uruguay is as good as the Paraguayan one, but we also built a table for the meat, and this was before the Pope, and Portugal, New York, Hollywood, Mexico, LA, and the San Remo Festival 2 years ago, the Festival of St. Lucia in Mexico. And these experiences create something deeper than just going to play in a certain place. They create experiences that change lives. This is the picture of 4 little girls when they saw the sea for the first time. And today, thanks to GeneXus, this history is repeated, because they saw the sea for the first time in Montevideo, some of us.
O la primera vez que tocaron la nieve.
Oh, this is the first time when they touched snow, and here when they got on a plane, this little one here, and when they played for Pope Francis. So we go from Metallica to the Pope. Why recycled instruments? Because leaving aside of these wonderful experiences, we don't forget the following. Without the community of Cateura, well, we wouldn't do it. And in other places, there are violins where a violin can be more costly than a house. And here in Cateura, a violin helps a child to play music and wholly develop. That is why we have tried to improve the lives of many families. We have built houses, and now we have our own premise, and there are 400 children studying music in this school. And we are going to improve the environment in that neighborhood. We are going to build these stairs in the shape of a piano, and there will be a script on each sideway. If you visit Cateura, you will be able to walk on the music and go listen to these children. This is the stairs as they are and as they are going to be in 3 months. This is how it's going to be very soon.
mientras ustedes esperan el bus, en la
And while you wait for the bus, you will also be able to play an instrument. So I'm just showing you how the community is changing. And everything is done with the participation of the children. They bring a little bit, all the little bits they find in order to build this great project. And this was the celebration for Children's Day. And at the entrance, there was a piece of floor that they had built. And this says that I have to take a flight to Azerbaijan because the story continues and the opportunities continue arising. And I say it again, we did not start by having, we started by doing, because doing has an enormous power. And what we do touches the lives of people, even if we are seated in a small place, a small office for 8 or 9 hours a day. So you have to think that what you do here touches the lives of people. And if we realize this, then we do what we do with much more conviction. Thank you very much.
Bueno, ahora vamos al hacer. Eso es el hablar todavía, ¿verdad? Entonces, vamos.
Well, it's very good to talk, but now we're going to do. And if you don't mind, if I'm not opposed, we are going to play you some music. I was told that in the audience, there are people of various ages, but I should play music of the average age, and in my opinion the average is 25. Is it so? Tops 27 on average. So you're going to like this music.
Muchas gracias. Bueno, como se dan cuenta,
Thank you very much. As you may have realized, Cynthia has grown up from that first photo of hers we saw, and the violin she's playing has been made with a piece of a paint can, and then on the back it's a pan, a cooking pan. This is where we make Paraguayan soups, and the wood is a palette, and here we have a fork. That's what holds the strings. So in GeneXus, I imagine that when you do software, you do updates too. How often do you update the software? Every year? Well, they say now, you say now, well, now we have the 2018 version, and we do the same thing. This was the previous version, and this is the 2018 model.
¿se nota la diferencia?
Can you tell the difference? Well, you have to update your material, right? And Cynthia played the violin, and now we will show you that the Paraguayan waist is also good for playing music in Montevideo. This is the most famous tango, and it's composed by a Uruguayan, or one of the most famous. It's considered like the anthem of tangos, and it's called La Comparsita.
Bien, muchas.
Thank you. Thank you. I would only like to thank you. I would like to thank you for this opportunity of being here. And I would like to say that the opportunity that we have here will be multiplied because the children of this orchestra here in Montevideo will play for recyclers in Montevideo and for several state schools in Montevideo. So what GeneXus has done with us has given us the opportunity and to generate that chain of favors so that together we can build opportunities and multiply them for others.
Queremos tocar una última música.
We would like to play one last song, a happy one, cheerful one, because we want to share this energy and happiness with you. And see you soon.
No sé para qué. Bien, y mientras los músicos van bajando.
While the musicians are leaving the stage, we would like to thank them and congratulate them on the capacity to create beauty, which is unlimited. Congratulations to the biggest one, to the smallest ones. Please, Fabio, because when we listen to you, there are many more questions and many more, and we would like to congratulate you. This is the first thing I have to do. I would like to congratulate you, and this is what people showed you with their applause. But first of all, I'd like to ask you whether there are any conditions to form part of the orchestra. Do they have to attend regularly? Do they have to school? Do they have a certain age? We've seen very small children. Well, I'm sorry, I can't hear. I'm sorry, there's interference. Well, the important thing is they start this process with us. Our music school is absolutely free of charge. We have no contribution or assistance from the state. The only condition is that you want to learn, you want to do something, because we reivindicate that culture is a basic need. In the same way as getting dressed or eating or having a home or safety, culture is one of the basic needs. And so everyone should have the opportunity to have access to culture. So the condition is wanting to learn, wishing to learn. There is no age condition. We have very small children, and we have mothers and fathers and grandfathers and grandmothers who also attend to come and learn with their grandchildren. So it's from 3 to 99, because learning is something that you can do at all ages. And how did you start? Because right now, when the orchestra is all around the world and is very famous, I suppose there are things that are easier. But when you start, sometimes it's difficult. How can you group them? How can you show them trust and the confidence from the neighborhood? Those of people who are not always wishing you to progress. Well, we always like to use the word process, because we know that in that process there are good things and there are bad things. There are achievements and frustrations that you know how to manage, that you should manage. And that was very hard because we didn't have absolutely anything. I myself don't think I'm a music teacher or orchestra director, and I'm an environmental expert. And I was criticized because people told me, how are you going to teach music if you are an environmental expert? And I was told, well, I can't go because there is nothing there. And I said, all right, so I'm going to do it. So we started from scratch. We started from wishing to do. And you, as an environmental expert, how did you get there? Well, I was hired to work in a process of selective collection, and I was the expert, and I met the families, I met the children, and I developed that immediate bond. I know that you have to catch a plane. I would like to go on talking with you for a long time, but how long have you been with this orchestra? 12 years. So that's been a record in your life, right? And if you have to sum up what you've had from this, what is it? Well, I've had many problems with my wife because I'm traveling once a month now. And now, luckily, I live with my mother-in-law, so she's happy. But it has changed my life because it's like a swamp, you know. It's and you go deeper and deeper, and it absorbs you. It's like moving sands, and well, we are at a time where no one has time, not even for oneself, and nothing outside your own interests many times. And here you are spending a lot of time, right? Well, yes. Are you also an environmental expert? No, I've got 400 children depending on me, 30 teachers, 7 tours from now until January, 20 concerts to be planified in Paraguay, and at present, our Cateura Orchestra is employing 100 people, and all of that on the basis of very simple idea. A strong round of applause, please. Thank you.
A ustedes les pido que no se muevan.
Please don't move, because we are going to move from music to space.
Bien, y les decía que vamos a pasar de la música al espacio.
As I was saying, we are going to go from music to space right away with Miguel San Martin, who is going to tell us about his trip from Viking to Curiosity and the challenges of descending in Mars and what it's like to work with NASA. Welcome, Miguel. Can you hear me? Yes. Firstly, I would like to thank GeneXus for having brought me here and giving me the opportunity to tell you about the work that we do in NASA in Mars exploration. And I always like to start my talk by saying why we explore Mars. Mars is one of the scientific objectives of NASA, but it would seem that for some reason we invest more money and attention in Mars. The reason is that scientists believe that at some point Mars was a warm planet that may have had life. It was similar to the Earth, and here we can see a river with a basin. And this would seem like the rivers that end in the river plate if everything dried up. So life needs water, and it would seem that 3,500 millions of years Mars had a lot of water, and maybe the right conditions were there for life to surge. And why are we interested in knowing whether there was life in Mars or not? Because we only know about life in planet Earth. Right now, we are only 100% sure of life on planet Earth. Therefore, if in our own solar system we can discover that life is not purely terrestrial and that there is life in Mars, then we could dare say that life is not a cosmic accident, that life happens elsewhere in the universe. Why do we want to know that? Well, because we want to know whether we are alone in the universe or not, which is maybe the most important question the humanity can ask from a philosophical point of view. This is a drawing that represents the possible oceans in Mars, and this is probably where the water was concentrated. Now, the first mission that went to Mars to test this hypothesis was called Viking. I was living in Argentina at the time, and it was a mission, however, that inspired me a lot. From the point of view of robotics, the cost was not the same, but the dimension was similar to the Apollo project that put men on the moon. Now it would cost more than $6 billion. It was necessary to invent everything, the computers, the motors, the radars, and the parachutes that we use even today. And what characterized this mission was that it had equipment to detect life directly, looking for metabolic processes and photosynthesis, looking whether there were any creatures that could breathe or that generated gases or that lived from plants, not very different from us. The vehicle was a great success. It arrived in Mars, and I was young. I followed it from my place in Rio Negro through the BBC, and the next day I went to the village and saw this photo and saw the print of Viking's leg, of one of its legs on Mars surface, and I decided that this is what I wanted to do. I wanted to study engineering and work on this kind of thing. And from the point of view of engineering, it was the ultimate technical challenge. So this is what took me to the US. People who are experts in arriving on another planet, and there are not many, found this rock which they named Big Joe. And in spite of the best intentions of landing in a flat place without rocks, analyzing the photos they took,
they were taking the photographs from the mothership where the vehicle came out. Well, they landed in a place where if they had landed some meters to the right, the vehicle would have hit the rock and would have been a total failure. So that's in the mind of the engineering. We made it. That's what we say, we engineers. And in the future, we have to do something different from this, because this system has large limitations. But anyway, we were there. I was in Argentina. The research went on, and one of the instruments labeled release showed a positive result. People from the Viking told us, the curve showing that there was life. Now, unfortunately, there were other scientific instruments giving a negative result. Even the instruments looking for organic matter, organic compounds on which life on Earth is based. And so perhaps the scientists from Viking thought that a bit arrogantly that if there was life, it was going to be life like ours. But that was what they knew how to look for. So they could explain that a positive result was false, and that the chemistry from Mars soil was quite complex, showing that type of life, which wasn't the case. In brackets, the scientist that designed this experiment is someone from MIT, thinks that the result was positive and that there was life, but the scientific community doesn't agree with him in general. Well, anyway, what's happened is that the possibility of life had been so much anticipated that a colleague of mine who was part of Viking and who's also working with us, and he was a very good friend of Carl Sagan, and he was so convinced that they were going to find life that Sagan tried to put a lamp to take a photograph of the animals coming out at night. When they didn't find any organic compounds, any microbes, unfortunately, they were so depressed that the Mars exploration program was killed. It was killed for 15 years. It was a great disappointment. Those were the exact years that took me to finish high school, get to the US, study English, get to university, and enter the JPL. But I never thought that the next mission to Mars, when I saw that first photograph of Viking on Mars' surface, that I was going to form part of that mission. But this one was going to be a very different mission. And now scientists, are a bit more intelligent, and they said, we're not going to promise that much. So instead of looking for life directly, we're going to look for the necessary conditions for life. And the first thing is that to prove that water evidence is true, that there really has been water on Mars' surface, and that strategy was called follow the water. The following missions had this follow the water thing. When we're talking about water, it's water that must be liquid and stable, good for life, forming rivers and streams with the right pH, not too acid or not too salty. And in spite of the fact that there are many organisms living in extreme conditions, anyway, we wanted scientists wanted to look for a more neutral type of water. And so that's what the purpose of this mission. And we also wanted to develop a new landing system. Why? Well, because what happened was that we had two problems. The first one was that we had to solve the problem of Big Joe, the one that almost killed the Viking. And the other one was that we had a much lower budget than Viking. It was less than $250 million. And Viking had used $6 billion at that time. So the idea was to find something much easier. So the first thing that we thought was, what are the things that are costly? Well, the costly things for space is computers, software, radars, gyroscopes, navigation systems. So this group of engineers, they were all mechanical engineers, they thought of doing something very mechanical, an air bag that could bounce. We were total enemies because we were pushing the price up in these missions. And even at the beginning, well, here you see the sequence of landing, which wasn't that easy, in fact, but the speed of the parachute was much higher than what the airbags could resist. So, well, they had to admit that they needed a radar and software. So bring in Miguel and his people to do the job, so that they could stop the vehicle in the very last second. And that required a certain algorithm that was quite delicate. As the legend goes, the head of the project was so mechanical, he didn't want any software. He wanted a sort of a mechanical temporizer like the old washing machines in the 50s. But then very quickly we persuaded him that we needed some software and a computer and rocket engines. So, but suddenly we realized it wasn't that easy, and it wasn't less easier than what we thought. This is a photograph of the Pathfinder. You see the Sojourner rover. There is a spaceship that is absolutely independent. That's the mothership with its own computers, and it manages the software for the trip to Mars and landing, and also operations on the surface. And then the vehicle is absolutely autonomous and comes out. Landing was very successful. This was one of the first photographs, beautiful photographs with Sojourn. Well, you can see the airbags. Once the vehicle lands, you have to retract them so that they are not mixed up with the wheels. And so there are some petals that open up. And in that way, the vehicle has the pedals down and the vehicle is up. And it worked until the first time we tried it out. Now, here we can see a photograph of the Sojourner exploring a rock. Now, some of the thing that we learned, that what was quite obvious, that while the Viking, well, scientists were very frustrated because they were analyzing the rocks around it, but they wanted to analyze the rock that was on the other side, and of course they didn't have enough space. So we said we had to solve that as well. So we need a mobile explorer. And that was the first experience for the US. The Russians had already done it on the moon. And so scientists said from now onwards, we want rovers. This is another photograph that's very nice. This is one of my favorite photographs at that time because it was a rover photograph taken by rover to the spaceship. Well, as you can see, this system, although it's passive and with airbags, it has its complexities. They complain about software and computers and control complexities, but this has its disadvantages as well. And I always reminded them of that to them, because sometimes we didn't do it very well. Well, the Pathfinder saved the life of Matt Damon in The Martian. I don't know if you've seen the film. I'm trying the way of using the north, and we laughed our heads off because most certainly he discussed it with one of my colleagues to see how he could find the north. Well, this was a mission of engineering to land something and to learn a more economical system, and the question of water. And then we had these two other missions that were hired. It was JPL. It was private industry. One was the Mars Climate Orbiter, and the other one was Mars Polar Lander that were going to land on Mars. And this was going to be the new mantra of NASA. And they were going to be done with a very low budget, showing that they could do things in a cheaper way and get to the same point with a little bit more risk. Well, unfortunately, they both failed. In the case of the lander, as I was telling the guys from GeneXus, it was one single code line that has taken 10 seconds to write to reinitialize a state barrier and write false. But I always tell young guys that in all these topics, 99.9% of doing everything right is not worth it if we have 0.1% that is bad or incorrect, because that could mean this tragedy. And so now what NASA is thinking about the next mission. There was a twin mission. So NASA said, let's take that to the museum. Let's have the same landing system that was successful last time. And that's how we had this Mars exploration rovers, which meant the Spirit Opportunity mission. It had the same landing system, but instead of having a mothership and a rowboat that was separated, what we did was to put wheels on the mothership, and we had only one vehicle that was hiding, you could see, all packed up in that pyramid, tetrahedron that is protected while bouncing. And that was the idea, and we said that has worked. Now we don't have room for failure because NASA was coming from, it was being quite ashamed having failed in 2 missions in a very short time, so this had to work out. Now the trouble was that very shortly after making the test, this system was very heavy, and we suddenly realized that, you'll see this was one of the tests of our airbags. So that kind of thing would happen, those holes there. The same thing had happened with the Pathfinder, but since the size and the weight of the vehicle were much higher, we came across all kinds of problems, and we could see that this is a very difficult system to model. It's practically chaotic, the way that fabric interacts with the rocks. And the only way to improve the system is empirically. And so we said, let's put some more fabric, or let's, instead of doing cross-stitch, let's change the stitch, and, things that we don't want to do, because we want the certainty that this works. And something that is so experimental is not something that we like. But, well, we were up to our ears in this, and we had to make it work. But once again, we can see what the problem is when you want to do things passively without control. And so you would move the challenge from one place to the other. You weren't solving anything. You were creating a new one, in fact, because this is a system that couldn't be modeled. And even at the time of despair, to try and understand, we put a plastic rock in it with pieces of rock to see how the fabric was interacting with the airbag. And we didn't learn anything from there, only that it was a very big problem. We didn't know how to solve it. So, well, mechanical engineers went on putting in layers of fabric. and we put in more complexity. And I don't have time to tell about all the details. I can do it outside, but we had to add computer vision at a time where everyone wanted to do mechanically, and now we have computer vision suddenly to be able to compute the speed of the vehicle and turn on some new engines to reduce the speed, the horizontal speed of landing, so that the wheels don't break down. So we ended up by having a hybrid system. It was mechanical, it was passive, but on top of that, we had to put all the intelligence of computers, algorithms, and even computer vision.
So this complex machine can be seen on this video. Actually, what we see here is an animation of the telemetry of the landing of the Spirit. So what you see here is what happened that day.
Al principio acá ya está el paracaídas.
Here we see the parachute already open and the system has been deployed. The rover is down there. And the radar is here making the calculations about the height and the speed in order to put the airbags at the right moment and cut the cord so that the vehicle is freed and can bounce. And this had to be done with a precision of less of 1/10 of a second. And the engine start, and you can see the height regarding the soil or you see how it bounces here. We received the telemetry after the landing. We couldn't have a direct link to the Earth, so what we did was to modulate the tone of the radio frequency in order to send some smoke signal saying that the vehicle was functioning and the parachute had opened, but the level was very low. And here you see how it bounces and continues bouncing. But it was a success. It in both cases, both missions went well, and we see here a photo like this one in particular. And it says opportunity in Aguila Crater. You see the construct and you see the bouncing of the airbags, which have ended up in a crater. And one of the interesting things, or another one, is, well, this is our carcass that protected the vehicle. And another interesting thing I was saying is that the geological material had to be investigated by a geologist in order to determine whether there had been water there. And not only had it functioned, we had already discovered something that had a lot of scientific value. But then came curiosity, and as you see, we are talking about a vehicle that weighs almost 1 ton and has the size of a Mini Cooper. When we showed this picture before the landing, the people from BMW, that are the owners of the Mini Cooper, sent us lawyers to tell us to stop showing this photo and making comparisons. And here we have the whole family of robotic vehicles, so that you see the leap between them. Curiosity required a bigger vehicle, and we really don't know how we are going to make it. And it was also necessary to reduce the size of the landing ellipse to a size that could be better determined. This is the place where the Curiosity was to land, and the mountain has less than 5 kilometers in height. It's very interesting because the mountain was also built by sedimentary layers that contain the geological material of Mars. So you can read it from inside out. The oldest, most ancient layers are at the bottom, and the most recent ones at the top. So we could find at the bottom whether the right living conditions existed. In order to land there, we had to reduce the size of our ellipse, and I'll tell you how we did that. I always said that it was landing between a rock and a hard place because we had the mountain and the crater and the edges of the crater, and all of them were very dangerous. So if we did not fall in this area in particular, we wouldn't be successful. So these were the 7 terrifying minutes, the 7 minutes of terror, and the stages were the same. The vehicle entry, you see it here, it arrives to Mars at on the highest to the highest layers of the atmosphere, and in 7 minutes it has to land safe and sound. And it takes 3 stages. Firstly, the entry in the atmosphere, when the vehicle brakes, when it gets in touch with the atmosphere and the friction of the atmosphere, the kinetic speed of the vehicle becomes heat energy. Therefore, it has to be protected by a thermal layer. Then, when it reaches 10 kilometers, it opens a supersonic parachute, which reduces the speed from 1,500 kilometers per hour to 10 kilometers per hour. The atmosphere helps to decrease the speed, but it's less dense than the atmosphere of the Earth, and therefore the vehicle is still falling with a parachute at 300 kilometers per hour. So it needs to brake once again, and that is why it has engines to stop it. So this is the first stage. We have here the capsule I told you about that protects the vehicle when it enters the atmosphere, and again comparison with the Mini Cooper. Once we landed successfully, we were still showing the pictures, and BMW was not complaining anymore. You can imagine why. And this is the thermal shield that protects the vehicle from high temperatures. In order to reduce the size of the landing ellipse, we had a guided entry for the first time. In the past, the entries were ballistic, but now Curiosity had a guided entry, which was the same that the Apollo used to arrive in the ocean near the ships that were going to pick up the crews. The engineers of Apollo died, unfortunately, during the Curiosity process. The displaced vehicle has to be put at the center so that the capsule comes at a certain angle, and there is a vector that can be regulated afterwards with the engines of the rockets, and the vehicle is guided like if it were a plane. All this is done automatically. The 7 minutes of terror, due to the fact that everything is automated and there's nothing you can do from the Earth. And the first time we tested it, it was in Mars, so we couldn't do anything unless through a simulation. So the tiniest error that we called unknown could spoil everything, and that is what would keep us awake at night. You can see here the various landing ellipses compared with the crater, how they were reduced, and the size of Curiosity, and the only one that could get to this place was Curiosity because it had a guided entry, and you can see how close it was from the center of our target. So it was the first time in which we used this technology. The following stage is a parachute, which is supersonic, one of the world's largest, 50 meters long, 25 meters in diameter, and we have a love-hate relationship with the parachute. We love it because it helps us a lot to break, and it helps us in size and volume. And we hate it also because sometimes it does not open or it breaks, as you see in this test, a structural test of the parachute that we carried out in Ames Research Center. It did not work, and this is one of the parts of the 7 minutes of terror that we fear most, because it's very empirical and difficult to model. This is a parachute that opens successfully. And you can see in slow motion the complexity of the moment in which the parachute opens. The conditions are not the same as in Mars, and it's impossible to model. And we hate everything that cannot be modeled. So we are at the mercy of what happens later. And then the third stage, it's necessary to make the vehicle land in some way. We used these airbags in the past, but we need the engines of the rockets, and we looked for ways of putting airbags. But imagine a vehicle of more than 1 ton bouncing again and again in Mars. We could put radars or anything because we had the money this time, but if you land a vehicle and stationed by 1 meter, well, that meter is very complicated. It's not easy to lift a car that is 1 meter high. You need ramps, but there's no place in the capsule for metal ramps, so we need something inflatable. And it tried everything until we had this idea of using something similar to a helicopter. And this is the final result in this artistic illustration and then in this simulation. All the physical aspects are well modeled, and we had a control system. And one of the novelties in this system was that the crane, the sky crane, keeps the vehicle until it has been completely deposited on the surface, until touchdown, and we could land on slopes, and also if there were Big Joe rocks. So it was a high vehicle, which thus became much more robust than in the case of biking. These are the tests we made so as to make sure that the mechanical part of the sky crane would work. But we never turned on the engines. The sky crane was tested for the first time in Mars. The landing is very benign. It's slow and nothing is broken. So it was quite simple. That was our motto. Let us land slowly, and even on Big Joe, provided the rock is not so high that it hits the belly of the vehicle. It required a very precise radar that we developed in the lab, and we had a lot of software and expensive computers, but we had designed a system that could be modeled, unlike the airbags. The radar required many tests and helicopters, as well as aircraft to reach supersonic speeds. All this was extremely expensive, but finally it allowed us to land a 1-ton vehicle. These are quick photos of different parts of the vehicle, the Curiosity, so that you can see the size compared to a person. This is the arm with the scientific instruments. I could do another presentation on this arm, and it has nuclear energy. It has a plutonium battery. It's not solar. More photos. That's me taking a nap. And now I'm going to show you a video so that you see how Curiosity landed on August 5, 2012. This is the camera and the photos it took during the descent.
El vehículo en este momento se encuentra bajo el paracaídas.
The vehicle is oscillating under the parachute, and I'll tell you the exact moment when it is freed and starts its flight under propulsion.
Ahí se desprendió el paracaídas, el vehículo está...
There it has freed itself from the parachute. It makes an evasive maneuver so that the parachute does not fall on top of the vehicle. That would be a very bad day in Mars. And now it's in vertical direction and it starts raising dust. You are going to see the wheels right before touchdown. That's the wheel. And this is the photo of the Curiosity. We see here Mount Chart and the wheels on Mars and the shadow of Curiosity on this Martian landscape. We fill Mars with waste, but fortunately the Curiosity landed safely and successfully. And then we took photos from one of the vessels that was in orbit. We made it take photos and when right at the moment of touchdown, and we can see the details of the parachute. This was the first movement of the vehicle outside of the landing place. This is a photo taken by the camera of the robotic arm, and you can see there the mount. This was the first selfie in Mars. And very quickly it started taking pictures. These geological structures are made with layers, as you can see. So geologists, my friends who explain things to me, have said that it is very clear that in all likelihood water had to do with the formation of these rocks, acted in the formation of this rock. And this is the bed, the dry bed of a river on Earth and in Mars. So it could be in Mars too the dry bed of a river. The rocks are rounded due to the friction of the water. This is the famous Mount Sharp. And we can also see the sedimentary layers. The robotic vehicle is going up the slope to study those layers. And I will leave you now with a video to show you how the landing was observed and celebrated in various places in the US.
Things are looking good. Coming up high. Vehicle reports entry interface. At this time, begin pressurizing the propulsion system to increase the thrust of the system. We use that for all the maneuvering in the atmosphere we're about to do. We're standing by for guidance start guided entry. We are beginning to feel the atmosphere. Digital separated, we're on the ground. We're down to 90 meters per second at an altitude of 6.5 kilometers descending. Standing by for maximum separation. We are in hard flight. We're at altitude 1 kilometer descending. Standing by for sky creating. Sky creating started.
Eagle Eye, being strong.
Touchdown confirmed. Receiving.
Bueno, esos fueron el resultado de 8.
So this was the result of teamwork. Thank you very much. These stories are very, very fascinating. And one of the questions was, this was just one shot. How long did it take you to work for this one shot? No matter how many adjustments you do, there are so many uncertainties. Yes, it was $2.5 billion and 8 years. 2.5 billion. Yes, we were a bit concerned. And I imagine that there has to be a lot of pressure behind it, right? Yes, there is pressure, but our bosses from the NASA, from Washington, had told us that these things are difficult, that it might not work. We had already showed that we had worked very hard, and that if it did not work, we were going to get up and clean the dust of our clothes and then try again. So they had taken out that huge fear of spoiling the party. And the worst thing is if something bad happens and you had something to do with it. Yes, without any doubt, after so much work and such huge figures. We were saying that you had to decide if a few days before touchdown, when the vehicle was already in space, you received a mistake, or what? Could you decide something at that moment? No, once the vehicle had left, there was no way of delaying the moment of touchdown. The laws of orbital mechanics establish that you are going to arrive on X day, and we left without the landing software. We had a beta version, and 2 months before landing, we sent it. Because we were told, well, no more changes in the software, and that was 2 months before landing. It was a Wednesday, but on Sunday I discovered with my team that there was an error in a parameter in the software. So what happened when you realize that? When you say, hey, listen, there's something I have to tell you. It's not for anyone. your blood pressure has to be very stable. Yes, and one of the things I'm more proud about working in HPPM, and it's the reason why we are so successful, I think, is that there is a culture of communication, teamwork. Yes, I didn't hesitate for a second to go to the chief of the project and say, Peter, we've got a problem. In my area, there is an error in the software, and we didn't fear retaliations. There would be retaliation if I had hidden the error. So that type of communication is rewarded. But the choices were not to do anything because we had to prove that the error could have very bad consequences. But if the consequences would not be so serious, well, doing the change and sending a command to the vessel and changing that parameter so close to landing were also risky. There might be an error in the software that could have worse consequences. So the tension was to prove that maybe we had to do it or not. So you told your boss, you decide or what? Well, it's a long story. I could make another 1 hour presentation. Did he ask you what would you do? Well, yeah, it was a long conversation. Finally, he divided the team in two. One part of the team, myself included, were told to analyze the consequences if we did not change the parameter. And we spent the whole night from Friday to Saturday studying the possible consequences and making simulations. And then the software team had to change the parameter and model the software and the hardware and analyze what would be the danger of changing the parameter. And then the next morning we all met and the chief of the project said this is the most difficult decision in my life, and I was not very happy about that. But we voted, and most of them, since we could not prove that not changing anything would lead to failure, well, I told Peter, we have not slept much. Maybe we have not done the right thing, but what I know is that during the last 4 or 5 years we have flown the vehicle in the simulation in one way, and this is a different one. So did you reach a consensus? No, the consensus was mostly not to change the parameter, and the chief decided to change it. But the interesting thing is that he said, although most of you have said don't change it because there doesn't seem to be a problem, I decide, and that's why he said it's the most difficult decision in my life, I decide to change the parameter. And immediately we went to tell the managers in Washington, the managers of NASA, about to tell them what we were going to do. And then he congratulated me. He said, good job, and he sent me to sleep. And I said, well, but I made a mistake. And he said, but you came and told me that you had made a mistake, and this is what we should expect. Very good teaching. And someone else said, why did you decide to change the parameter when all of the experts were telling you that it was not necessary? And the answer shows why he was the head of the project, this $2.5 billion, him, not me. He said, because I wanted the team to stop thinking of the problem and to start thinking of the next problem. If I had not done it, I know that Miguel and his team would have continued getting distracted by this issue. But so we had to get it off the table because we had to land in Mars the next day. So it was not so much a technical decision, but a human one. He needed the team to stop worrying about this matter that had already taken too much time. So finally, when it worked, phew, let's not do it again. I'm not going to ask how you celebrated that day. Yes, it was real fun. How many people work with you in the team? Well, the maximum for curiosity inside our team was 800 or 1,000 people. Not 800,000, 800 to 1,000. But we also bought many parts from other companies. For example, the thermal shield was made by one company, and so was a parachute made by another one. At the end, we were 200, 300 people. And finally, to end, what keeps you awake now? I am working not on a project, it's a study, trying to convince NASA and scientists to turn this study into a project in order to land a scientific station in Europa that is a moon of Jupiter, and it has a layer of ice, and underneath there is a liquid layer that might have the conditions to have life nowadays. In Europa, unlike Mars, there would be life now. So the landing system will have to be very different in many aspects because we don't know much about the surface of Europa, and we know that it is very complicated, and we would have to design a vessel that could also stand the radiation. And when do you think you could get there? Well, the plan we are submitting to NASA is long-term, a long-term plan. It would start in 2026. Therefore, we should start now, and the landing would be in 2033. So it's gonna take a long time. Yes, that's a lot to do. Thank you, Miguel.
A ustedes los invito a disfrutar del último coffee break de la tarde. Luego
I invite you to enjoy the last coffee break of the afternoon, and then
to the coffee break.
we are going to listen to Breogán and Nicolás at 5 o'clock.
asiento a los que todavía no lo han hecho.
Please be seated. We are going to listen to the main keynotes, but as we do every year, we'd like to ask Breogán Gonda to come up the stage, and Nicolás Jodal, a CEO of GeneXus. Very welcome. Welcome. And as it happens every year, we would like to recognize those people who have an outstanding role in our community.
Primera aplicación integrando inteligencia artificial en el GeneXus con.
So we are giving this recognition now. And Gabriel Campbell, please.
Adelante, Gabriel, bienvenido. El proyecto de GX28 fue llevado adelante por Gardau Liza utilizando SAP Leonardo. Muchas gracias, Gabriel. Felicitaciones. Con la implementación de soluciones de emisión crítica a la autoridad del Canal de Panamá y recibe el reconocimiento.
The authority of the Panama Canal, please.
Ahora, Aristides. Autoridad del Canal de Panamá es la responsable de la administración del canal desde el año 1997. Bienvenido. Desde su apertura el 15 de agosto de 1914, el canal ha dado un servicio de calidad a más de 700.000 barcos. Muchas gracias. Por su liderazgo en la transformación digital del Estado y la incorporación de Uruguay al T7, entregamos este reconocimiento a AGESIC. Recibe José Clastornec, director de AGESIC, la Agencia para el Desarrollo del Gobierno Electrónico. Adelante, José, bienvenido. Felicitaciones. Gracias a más de 10 años de políticas digitales de Estado, Uruguay fue incorporado al grupo D7 que integra junto a Corea del Sur, Estonia, Israel, Nueva Zelanda, Canadá y Reino Unido. Los principios orientadores del grupo apuntan al desarrollo de la conectividad, la ciudadanía digital, la programación desde la niñez y el gobierno centrado en las personas. Con la implementación de ciclo ágil en GeneXus para el desarrollo de una solución multi-experience en la industria de retail, entregamos este reconocimiento a I+D y recibe Laura Guiar. Adelante, Laura, felicitaciones. I+D es una joven empresa de desarrollo de software que ha construido una aplicación de retail basada en el desarrollo ágil con GeneXus, logrando una solución robusta de e-commerce. Por su compromiso con GeneXus e implementación.
For his commitment with GeneXus and successful implementation of projects in the financial industry, we give this recognition to Action Point of Argentina. We welcome Action Point Jorge La Bombarda. Action Point is a software development company in Argentina offering services in GeneXus for over 20 years, and at present it has reached the level of diamond partner of GeneXus. Due to the implementation of BPM with GeneXus 16 for the China financial industry, on behalf of GeneXus China, Xue Shanyu. Beijing Transino, through GeneXus China, has achieved the implementation of a complex system based on BPM with GeneXus 16. due to its contribution to digital transformation in the industry of travel and tourism. We award this recognition to Netviax. Alejandro Garrido, please. Netviax offers services of software development to the tourist group that is the largest in the country and has developed its Atlas app and latest technologies such as chatbots and OData. Congratulations, Alejandra. Due to the early adoption of GeneXus 16 in the migration project from K to B ERP, this award is to K to B, Cecilia Belletti and Maida Kurdian. Cecilia and Maida, congratulations. K2B ERP is one of the largest dissemination ERP within the GeneXus community and has placed state-of-the-art technology in GeneXus, adopting version 16 early. For its contribution to the dissemination of GeneXus technology upcountry in Uruguay, we give this award to Arturo Bentancor. Arturo, please. Arturo is from Juan Lacase, Colonia, in Uruguay. Arturo Bentancur is GeneXus developer, has been a GeneXus developer since the beginning, and at present he is generating new opportunities for Juan Lacase citizens, reconverting them from the labor standpoint. Thank you, Arturo. For the digital transformation of in the forestry industry, this award is to Montes del Plata, Fabián Fajardo. Montes del Plata is part of Stora Enso, an important forestry industrial company in the province of Colonia, and has introduced new technologies and innovation to its production process. For its constant work of evangelization in the United States of America, we give this recognition to Jeff Parker. Jeff Parker. Jeff is a GeneXus user, has been a GeneXus user for many years, and right from the beginning has participated actively in the growth of the GeneXus community in the United States. For his contribution to the GeneXus community in Brazil, this award is for Alexandre Lucchini. Please, Alexandre. Congratulations. Alexandre is a GeneXus, has been a GeneXus developer for 20 years, and since the beginning he has actively participated in the GeneXus community in Brazil, helping to the growth of GeneXus in that country. Due to the development of applications of critical mission in education, this recognitions to the Center of Computing and Automation of Santa Catarina, Brazil. Sandro Magrinelli, please. CISC of Santa Catarina in Brazil is the body responsible for the implementation of policies, management, and services of IT and electronic governance of the bodies and entities of all the state public administration of Santa Catarina in Brazil. for the development of web and mobile application of public service based on innovation, integration, and transparency. This award is to the Prefeitura de Blumenau in Brazil. And we are calling up front Mr. Eric Boeing. The Prefeitura de Blumenau has recently received a prize, UDESC ESAC, of good practices in public management because of its health system developed with GeneXus. Very well. We are now going to recognize people in our company for the first 20 years in the GeneXus equipment and GeneXus team. Armin Bachmann, Ana Berta, Cecilia Firpo, Graciela Liston, Pablo Mazzilli, Bernardina Molinolo, Diego Rivero, Ignacio Roqueta. Congratulations to all of you for your first 20 years in the company. I'm sorry, I can't hear the speaker. There is music around. I can't hear the speaker. There is music. Music is too loud. It's overlapping the speaker. I'm sorry. I'm sorry, I can't hear the speaker. The music is still too loud. Those listening to the English booth, please ask them to lower the music. I can't hear.
nosotros creo que
Thank you. I think that in some way this is representing us. It doesn't rewrite us.
¿Y por qué? Bueno, si nos
If we place ourselves at the beginning of all times in GeneXus, Nicolas and I were behind what seemed to be a chimera at that time, automating everything that could be automated in the development and maintenance of systems. We believed in that. Perhaps no one else believed in that. And we had many difficulties. In fact, when you're going to do something new, you're going to come across many difficulties. But there's a fundamental one that helped us a lot, is that we came across a much bigger problem, much bigger than what we thought it was. And we came to the conclusion that it was very difficult to solve it with a manual programming. I don't know if it was impossible or not, but at least it was very difficult, and we couldn't do it. And so we faced artificial intelligence. In some way, the decade of the 80s was very similar to the present times. Because there was a strong euphoria about the possibilities of artificial intelligence that was overvalued, most likely, and the fact showed that it had been overvalued. It looked like a panacea. It looked like the solution to all our evils. And we said, well, this could be the solution to solve such a big problem. Because to solve a problem with a program, you have to transform the problem, which is an enormous group of rules, using an algorithm, and then write the algorithm as a program. And that's very difficult, and it's full of errors. So we thought that it was a big solution for us, a great opportunity, this artificial intelligence. But of course, there's a minor detail there, which isn't very important. We didn't know a thing about artificial intelligence. And so, in general, artificial intelligence teams at that time, where risk investments were, following artificial intelligence companies, in general, they would work with two teams. One team was made up of experts in artificial intelligence, and another team who were the experts in dominating the problem. And we were two daring men at that time, and we formed part of the two teams. As experts in the problem, we were consultants on a database, and we were quite known at that time. And that was a strong point, it seemed. And as regards artificial intelligence, we didn't know anything. So what happens when you don't know anything? Well, you learn. And how can you learn? Well, let's take a master's or a PhD. And perhaps we couldn't afford it, but we could discuss that. But it was clear that we couldn't do it because we didn't have time to do it. Formal education couldn't help us. And so the way out is to learn by doing. And we did well. And we were able to solve the problem. And by the end of the decade, we launched GeneXus as one first approach to what we wanted. But to do that, and having faith and having determination and sweat, blood, and tears, well, we got some bonus there. Well, there was a problem we had very frequently, that when you are doing research work, when there are no roads, because no one has paved them before, you know, the only thing is that you pave the road as you walk. Well, many ideas occur, and sometimes those ideas you discard them and reject them because they're not good, or that they can't be applied. But there are ideas that seem to be very good. And what do you do in that case? Well, in that case, you build a prototype to validate those ideas, and that program, you test it, and then you say yes or no. Only that a prototype built with traditional methods was taking us a couple of weeks, and that was very expensive for us. Using methods and tools of artificial intelligence, perhaps the same prototype could be built in 2 or 3 hours. And we would discard the same ideas, I suppose, but it was much cheaper. The other bonus that we got was even more important. We came to the conclusion very quickly that something wasn't working there where we thought we were strong, our role as experts on the problem, which was our force. But we could see that, in fact, the expert provides knowledge, conveys knowledge, and that knowledge is turned into algorithms, and we codify them. Now, the problem wasn't a question of codifying algorithms. The problem was lying at the source of the knowledge. We human beings who are experts in something always think that we know everything about the topic. That's never true. But in that communication, there is always a strong subjectivity. We thought that that was happening to us because we had particular problem and because we were ignorant of the tool called artificial intelligence. And so we came to the conclusion that since we are not good as experts for this, let's obtain knowledge from somewhere else. Let's take away knowledge from data. And that was a strong bonus that destiny or fate gave us, because by the decade's end, we were launching GeneXus. And at the end of that decade, at the same time, practically all artificial intelligence companies were going bankrupt. And then facts showed that the problem lied with the sources of knowledge. And artificial intelligence went back to being successful, particularly as from 2010, when it was possible, on the basis of data, to obtain the knowledge it requires.
El destino nos ayudó.
That is to say, destiny helped us and gave you as an advantage of 20 years, thanks to that difficulty. But let's go back. The power of doing is very important, but not as a motto. The power for doing has to be based on learning by doing. And this is a general truth. It's the basis of any research nowadays. And it will be the basis for the new education systems that will impose throughout the world when we are convinced that teaching is something that we started doing 500 years ago, but it does not have a future unless we change the focus from teaching to learning and from the teacher to the student. And this applies to everyone. Now we're going to speak about artificial intelligence, right? And it's amazing, but everybody speaks about artificial intelligence and everybody has an opinion. But I would say that there is only one thing that has more experts than artificial intelligence in the world, and it's football. Because everybody in this planet believes that they understand the problem and they have an opinion. And let's go further. Some are even so daring that they write about the matter. However, artificial intelligence is much more serious than football, and for good and for bad it will have very serious repercussions in the world. So I'm concerned about those who say that robots may have feelings, or the ethical problems we should take into account in this case, and how we should protect ourselves from robots so that they don't attack us. But this is science fiction. In fact, we have made a lot of progress, especially during these last 8 years with regard to artificial intelligence. But things are not as sexy as people think. What we have today, what the world has, and this is very important, is a set of algorithms. Algorithms with which we are able to obtain new knowledge, to operate with this knowledge, and to obtain results that otherwise we would be unable to obtain. All this based on these algorithms and on an amazing increase in computing power. So how are we doing in this regard? The repercussions in the world are enormous. In every activity, there's something of artificial intelligence. Well, no, in every activity, there are problems that could be solved with the help of AI. And this is very different. But what there is a lot of research. And there is a first level, the high level, which would be discovery. And this high level is reserved to enormous companies that have significant resources and big research teams, and also have the time that and the money they can dedicate to this research. In the Western world, which is the one I reasonably know, there are very few of them. So it's mostly Google, IBM, Microsoft, SAP, and there may be one or two more. Why not Amazon? Well, because Amazon has the resources and the significance to do it, but they are dedicated to many things. Why not Apple? Because Apple is interested in the periphery. They are not interested in the deep research that interests us, for the time being at least. So there are other players, as we saw in some of the presentations. There are some important players, for example, in China. But how many are there in all throughout the world? 10 companies, give or take. And these companies develop very valuable technology with significant repercussions and quite difficult to use. And this is the first level. If we had only this, only these companies would be able to develop things with artificial intelligence, because what they do is not at the level of everyone, of regular mortals. And then the second level I would call domestication. Who are the players? Well, firstly, the same players which, after the discovery, are transformed in APIs or products, where the complexity is hidden to a certain extent to make them easier to use. And who else? It's not that huge companies are needed. What is needed is a lot of imagination and agility. There cannot be a system that make decisions in a slow manner. They have to be made on the spot, and there are many. So there may be many of them, and the first one is GeneXus. Why? Well, because from the beginning of times we are a domesticator. We have always done this with the more diverse technologies. In some way, we have created a layer of abstraction, and we make everything easier. And those who actually are going to use the things don't need to get into a lot of complexities. The others do the same, but we are in that field. We are in that field, and we have the experience of having done it since the beginning. And how many more are there? 20, 2,000, 200,000 companies? I don't know. But I would say that 20 is a reasonable number, because we have all learned that reinventing the wheel is not a good business for anyone. So we are thinking of 30 companies, maybe, some of them very big, but none of these 30 companies has the vocation of making systems for the end users. We all have the vocation of making products so that third parties solve the problems. So we have an enormous technology, but we are far from real problems. And there is, or there should be at least, another level. The level of solving real problems of real companies. And in this case, you need a lot of people and a lot of enterprises. And what's the profile we need? We need specialists in artificial intelligence? No. Of course, it always helps to have a conceptual knowledge of things. Especially it helps to feel good. But technology and their use have their own solutions. So it's not specialists that we need. In the century of specialists, it seemed essential to be a specialist. But this is the century of generalists. So we need people who go to the end user, who understand their business or his business, who finds the difficulties and the opportunities, and who is capable of describing these difficulties and opportunities with reasonable objectivity. Since this does not exist, and if we don't manage to create it, everything's going to be a big disaster. We are all partners here. We are competitors. And if the market is endless and we have the possibility of doing things with the hands of those who are involved is very restricted, what's necessary is a lot of efforts to develop the market. In particular, there are some obvious questions: what, why, how, where, when, who. There may be some questions that are already answered in the products that all the players make, but there are questions that cannot be answered. Where? That's the other side of the counter. It happens in the home or the office of the prospect. In principle, it would seem ideal that the prospect has the right professional, but it's not easy. Are there other resources? Yes. much more direct resources, and they are the small and medium-sized software companies that take care of the end user and end up also understanding their business as much as the client's staff. In your case, well, I need to get to you, and I need to get to the GeneXus community. But each one of these players needs to get to their ecosystem. And when? That's another question. The when points out to big differences. The when for the client and the when for me. I say next year I'm going to have XX thing, and I'm in awe about what I'm going to have. That's my when, the next version. But the client's when is now and here. For the client, next year does not exist. Secondly, he's not to be thrilled by the elegance of my solutions. I'm not going to be assessed on that basis. He's going to assess me based on the results his business obtains. And the what? The what is what we have to look for. Let's look at GeneXus for a moment, because everything I've said is valid for GeneXus and is valid for others. We have a strong community. When Nicolas and I started this trip 34 years ago, we were quite alone. When there are no roads, when you have to build your own roads, and there's no background to what you're doing, you feel very lonely. But little by little this changed, because others came along, and there were distributors or dealers, and there were partners and software companies and clients, and that's what created little by little the ecosystem. At the time, we didn't even know that's how it was called. But it grew and grew. And today it involves hundreds of thousands of developers throughout the world. So here there is an enormous opportunity. When? Now. For the GeneXus community, there is an opportunity, a window of 2 years, I would say, during which we have things to do. And for this purpose, we need, on the one hand, some formal actions from GeneXus in order to complete and innovate. But do not wait for formal actions. Each one should think of his own part. And I'm thinking of 200,000 people working on this. Well, maybe not. Maybe I'm thinking of starting 100, 200. But bear in mind that I'm not going to choose you. You are the ones who choose yourselves or dare or apply, and then inevitably the Darwin law will be applied, and those who survive will be very successful. So it's an enormous opportunity for you and for us, for this whole community, a community that has almost 4,000 people who have been participating in this event right here, personally, and more than 20,000 participants. Or 20,000 was the figure for last year, probably this year it's much more, who have been attending the event remotely. So there is an enormous power for doing, and let's do it. And this is an opportunity that won't be repeated, and we have to dare. We have to get out of our comfort zone. We have to tie our shoes and of course there's many satisfactions and many risks in all this. Without risks, nothing can be achieved. And there's always a strong component of courage, sacrifice, sweat, and tears. So this is what I invite you to. Thank you very much. Thank you very much, Breogán. Thank you for helping us think with your concepts and also leave our comfort zone. And we are almost at the end of the event, and it's time to invite the CEO of the company, Nicolas Jodal, to tell us what he's been thinking about this last year. And the title is People vs. Tech. Thank you, Cecilia, and congratulations. Thank you, my friends. Welcome. This is a talk that Breogán called many years ago a sports talk, in the sense that I'm not talking specifically about GeneXus. I'm talking about topics that are related to GeneXus, in my opinion, whether in the short or the long term. In the short term, for example, digital transformation, things that were very urgent and concrete, and other things I feel will end up being relevant for us but cannot be applied immediately. I remember that in 2014 I spoke about bitcoins, and I remember some of you were looking at me like saying, what is he talking about? And throughout the year, however, I'm invited to repeat my talks in many organizations, but in 2014 no one invited me, until 2017, when I was invited once a week. And today, one of the fundamental tracks was blockchain. That's how I feel today, but with a different topic. It's not something immediate, but I have the impression that it will have a strong influence on all of us. Unlike bitcoins, and remember that at that moment, persons didn't exist. Satoshi Nakamoto came up with a technological marvel out of nowhere. But the story I'm going to tell you today is different. That's why I called it People and Tech, because it's a story about technology and about people. A story about excellent decisions that I found very wise, people who behaved well, people who betrayed, engineers who worked for many years convinced that what they were doing was impossible. So I think that you should look at this talk from two dimensions: the dimension of technology, what people thought was impossible and still was achieved, and the people who did it. The story is about something that seemed very difficult or impossible to obtain, a self-driving car. So I want to start this story of people at tech in 2004. DARPA, the agency of the Ministry of Defense, which is mythical for us who work in technology, developed things with a military interest, but ended up developing things for the world in general. Internet is a clear example. But at that time, in 2004, the US were at war with Iraq, and people who were dying in the desert in the jeeps was one of the biggest problems. So they tried to create a self-driving jeep, and the wise decision was that they decided not to have a long research project with a very big budget. They decided to organize a challenge which was called the Grand DARPA Challenge, and it was supposed to have drivers who would cross 150 miles in the desert in less than 10 hours, and the winner would win $1 million. So several participants intervened in the first challenge. This was one of them, and it doesn't look like a hammer, but it's a hammer because it had so many sensors that they had to cut the roof. So Camilo was one of the participants, and he thought he could win. This one intervened with a truck. It was a self-driving truck. He doesn't even have a cockpit. And then another one who proposed a motor, and it looks like an animal to some extent, but it's a motorcycle. So the challenge started with the press, etc., and I'll give you an example of how it went. What you see here is the motorcycle that starts. It didn't even travel 10 centimeters. Afterwards, they found out that what had happened was that the guy on the motorcycle forgot to turn on the gyroscope, which would have give him stability. If he hadn't failed, I think that today we would be driving, or we would be on self-driving motorcycles. The director of DARPA had all the press there, and all of the participants failed. Caris Melo only traveled 7 miles and was the best one until he got stuck. So it was a total failure. Imagine the director of DARPA and the headlines the next day on the press. I can imagine sports journalists saying the desert was deserted or collapse in the desert, things like that. And without consulting anyone, DARPA's director said, well, this failed, but we're going to have the same challenge next year in 2005, and we'll offer $2 million instead of one. So they changed the logo. When things go wrong, it's good to change the logo. They changed the logo, and let me introduce the participants of this new challenge. Once again, Caris Melo with the hammer. The sensors were smaller, so they didn't have to cut the roof. And Caris Melo and also Stanford University had a presentation and wanted to see whether the university had to intervene or not. And this last slide said Stanford has to intervene in the challenge, and the last one said no. So they said no to Stanford, but they participated anyway with this Volkswagen. And several participants intervened. So this one had its engine stop at 60 miles. The engine, it was a mechanical failure, nothing to do with the sensor. He tried to turn on the software, but he arrived later, and this was the winner, Stanford. For the second time, Caris Mello, who was Carnegie Mellon, was the person who won, and he was asked what's the next challenge, and DARPA said, we are going to have a challenge in a city. City that turned out to be an abandoned base in the US. It was called Urban Challenge, and they had to travel 60 miles in a period of 6 hours. But it was a city that had to comply with all transit laws, but would be simplified. There would be professional pilots, but no one on foot or bicycle, no dogs, no lights in the crossings. So once again, Mello decided to participate with a sponsor that was General Motors.
And so this is Cevita Holle, Stanford also enrolled, supported by Volkswagen, with a Volkswagen Passat. Who won? Caris Mello. He had failed twice, but he ended up by winning the challenge, and a little bit longer, but he did. And that's something else that is interesting, and which I felt was extremely weird. The DARPA director was asked, well, what's the next challenge? And he says, there's not going to be any other challenge. DARPA has already fulfilled its mission. And I think that was very wise, because if DARPA had continued carrying out these tests, we would have specialized cars to win DARPA's challenge instead of autonomous vehicles. And it's important to say yes, but it's also important to say no. And so to conclude this first stage of autonomous cars, let me tell you about this question of technology and person. The best, or the winner was LARDA. It was something that is on top of cars. You know, all autonomous cars have something on the roof, and what they have is this LiDAR radar, which is the eyes of an autonomous car. It's like a laser beam that measures very accurately all the objects around. That was the winner from the technological standpoint. From the people's standpoint, these were the three winners. Look at them. One of them is going to be the bad guy of the film, of the neighborhood. Who do you think it is? One of them is the bad guy. Let me introduce you to him. Sebastian Thrun from Stanford University. The second one is Chris Erbson from Carnegie Mellon University. And the other one is Lewandowski. He's the guy of the motorbike. And well, the first two were obvious. And Lewandowski was the winner because he realized that the basis of a car, of an autonomous car, lied with the sensors. And so he went up to university and he told them what he thought about sensors. So by 2008, DARPA said it was not going to make any other challenges. Volkswagen had won and the two universities had won. So they expected that all those players would continue working on autonomous vehicles. But none of them had any interest whatsoever in building the autonomous car. Not even these three people were interested in continuing with autonomous cars. Why? Because they had all drawn the conclusion that they had gone up to the top and you couldn't do more than that. No one believed that an autonomous car could be developed except for this one, Larry Page, who is Google's founder. He's the only one who said, we must make an autonomous car. he called Sebastian Thurn from Stanford University. He said, Sebastian, what I'd like to do is a car that is autonomous in California. And Sebastian said, it's impossible. We are the best. I know the best team. It's impossible to have an autonomous car. And Larry Page said, another wise decision, he said, don't say no and don't answer now. Come back tomorrow and tell me the technical reason why you can't build an autonomous car, either because of the processor, the number of neurons, LiDAR revolutions, I don't know. But say no because of a technical reason. And so Sebastian went away, came back the following day, and he said, I haven't slept the entire night, but I really don't find any technical reason why not, but you can't. So Larry knew a little bit about how to deal with engineers, and he said, all right, well, we're going to have an internal challenge in Google called Larry 1K. Now, Larry 1K meant 11 tests, 1,000 miles, and if the autonomous car ended up those 1,000 miles, well, there was a good prize for the team. I don't know what the prize was, but I know that they were all very happy when they won. So what did Sebastian do? He had to set up a team. What we know, those of us who know about sports, what's the worst thing you can do? Create the team of the stars. And he did. He created the star players. He hired Thrum, Ursum, Lewandowski, and he said, we are going to make an autonomous vehicle, and we want to win the Larry 1K. Just that. That's what he wanted to do. He wanted to win. They had enough budget, and he said, give me a Prius, Toyota. That's the one they used. Let me show it in the inside. That's quite similar to any car, but let me expand one part. There it has a red button. And that red button is that in case something wasn't done, something was working wrong, then the driver would start driving manually. So the question of the button was because of the legal department of Google, because one of the questions asked to the legal department at Google was is this legal? Can we really have an autonomous car in California? And so Google's counsel didn't say, obviously no, obviously it's illegal. They said, well, you know, we've been reading the legislation very carefully, and we came to the conclusion that it says that there must be a driver. It doesn't say that the driver must drive. Okay, very good counsel. And that's why they put that button in. Now, the thing is that they had very large challenges. All the other cars that were autonomous, they never had a human being inside. And so one of the things that happened at first is that human beings were getting dizzy, and it was too sudden, and human beings would get dizzy. So they had to go along millions of miles to do things. And a couple of months before the end, in late 2011, the guys were able to pass the 11 tests. The first one was very easy. It was to go on a track, but the last one was to drive in the city center, downtown San Francisco, where there are many ups and downs, and they were able to have the autonomous car going around downtown San Francisco, and they had no problems. They did it perfectly. Now, and then they collected the money and so on and so forth. But this Langtech and the team wasn't working very well. There was an ego fight at that time, and something else happened. What happened is that another Google vice president, who had nothing to do with this, but didn't like something, he said, all right, let me see who is LiDAR's manufacturer, because they were buying that LiDAR to a company. And he said, are you the owner of this technology? I said, no, I'm not. I mean, we buy this technology to another company. And so this VP goes to the other company, and he says, and who Are you the owner of this technology? Good. And who is the owner of this company? And when he finds out who the owner of the company is one of these three guys. That is, there was one in the team who was in Google. He was buying a radar that he was building himself, that he was manufacturing himself. Who was it? Let me make it easier. It wasn't Sebastian Thrum. These two, out of these two, Carnegie Mellon or the crazy guy of the motorbike? Yes, the crazy guy of the motorbike. Anthony Lewandowski was the one meddling around. What does Google do? Now, he's an incredible expert, and he was the one who won the Larry 1K. Perhaps if Anthony Lewandowski hadn't been there, they wouldn't have done the Larry 1K in the deadline they had. So what did Google do? Well, this is a story of good and bad decisions. Just judge this. Well, it bought its company. It paid $20 million for it. Anthony Lewandowski was extremely happy, but it was devastating for the team. Imagine, you're working with someone, he was doing whatever he wanted, and he's given $20 million for having acted not very correctly. So, well, we come to 2012. On the one hand, it had been shown that an autonomous car was possible. And in 4 years, technology had developed with no problems, and so on and so forth. On the other hand, the team was very complicated, and there was a little detail there as well. Nobody knew what business model to do with this, and how can we make money out of this? What's the business model for an autonomous car? And that's a typical thing of Google. First of all, Google finds an invention, and many years later, he finds the way to make money with it. The first example was the question of the search engine. It invented it in the 90s, and until 2000 and 2001 had no clue how to make money out of it when it copied a business model from somewhere else. So we come to 2012, and the situation is there are no longer any challenges, no longer DARPA, no longer Larry 1K. He had been paid, and so we go into the model as to how to look for a business model and make all this feasible. The car industry was going through two very deep transformations. One is the electric car, the one competing with internal fuel. Tesla was the first one to do it successfully. And why is this important for this story? Well, because electric cars is a simpler magnitude car. An internal combustion car has 10,000 pieces. And an electric car has 1,000 pieces. So it's far simpler and far simpler to control and to manufacture. So this means that the barrier of the number of manufacturers is much lower. There may be other manufacturers. Much easier to make electric cars than the other cars. And the other transformer is Uber. And we've already discussed it at length. It's Uber. Uber starts becoming a model of transportation which is non-traditional. So Google team had to find what the business model was. And now the first attempt was, instead of building the autonomous car with a lidar on the roof and so on, let's do something that helps you to drive on the road, that it has cameras with no lidar, and that it can help you, you know, that it can brake and can turn around, and but it's not autonomous. And since it hasn't got a lidar, if there is a problem, well, the car would warn you, and there you drive it. Now, Google tries that out and comes to the conclusion that it's a very bad idea and a dangerous one, because you know, you're not driving the car, you're bored, and you're too bored, you don't pay attention, and then and then you're doing something else, and then there's a beep beep, and you have to react. And Google had come to the conclusion that somebody takes between 10 to 15 seconds to get into the context when it's not paying attention, and that could be from 100 to 300 meters, too late for any problem. So the first thing that Google does is to discard that, and what happens is that Tesla comes up with exactly the same. What Google was saying was bad and dangerous, Tesla comes up with the same thing. And it tries another business model, and it tries to license technology to large manufacturers. Let's go up to Detroit and make a presentation there. They go to Detroit, they make a PPT to the board of one of the large companies. I don't want to say the name. And Larry 1K was there, and they told them about it and said, "Well, look, stop here. You are telling me that you had an autonomous car in downtown San Francisco." "Yes, but the legal department said it was not." "Well, he said, I don't care what your legal department said. Go away." And they were dismissed from the meeting. That is not the way the automotive industry works in this country, he was told. So look, they have a pilot model which was too dangerous. On the other hand, manufacturers hated Google. So what did Google do? Let's make a car. And this is the car. Do you like it? It's strongly influenced by the legal department. True story. Why? Because the legal department said, if you do something that rides at less than 25 miles per hour, then the legislation doesn't apply. They were traffic specialists, and that's the car. It was called Firefly. If you sit in the inside, I remember we saw it with Villar once. It's like being inside the living room of a house with no brakes, nothing, no pedals, and the car would move. That was it. And at a certain point in time, they said, that's all right. But what happens is that if you got a car like this, it's very boring. Who would like to buy a car like this? And they came to the conclusion that this wasn't a car to be bought. So what are we going to do? Well, we're going to give it as a service. And when they said that, somebody had thought and had made a study and said, what happens if I replace personal cars of each one of us and I provide a car service that is autonomously driven, and I put in the restriction that whenever I call for an autonomous car, it has to get in less than 10 minutes or 2 minutes. If I have a private car, how many, if I have 100 private cars, how many of these cars do I need to replace them? Well, the study says 15. Somebody said it was a lie, but all right, that's what the study says. I can replace 100 cars by 15 autonomous cars. So that's what Google tried to do, and it was working with Firefly with it. But as I said, the internal situation was very bad between Lewandowski and Ursum, was quite complicated. And at a certain point in time, Lewandowski left the company, and in August 2016, several things happened. Sometimes in these stories, things are condensed at a certain point in time. There are a lot of time when nothing happens, and then at a certain point in time, everything happens very quickly. And so in August 2016, 3 things happened that are very important. Now, the first one is that Ford and GM announced self-driving taxi services. They did it separately. What's important about this announcement is that they are validating Google's model. They don't say that they are going to sell cars that are self-driven. They are saying they are going to provide a self-driving taxi service. The second thing is that Lewandowski had left Google, so did Chris Urmson. And he founded Aurora, a company. Sometimes you write about the mission and the vision and the values. Now what did he write about the values? He said one single rule, and it says you put honesty, transparency, that kind of thing. And what he did was no jerks, he said. He didn't want to have any Lewandowskis in his life. He wanted to avoid what had happened to him before with the autopilot people, working with Tesla, the endogamy in this. There are very few people who know about a self-driven car in the world. And then on the other hand, Uber was a company that was feeling extremely threatened with self-driven cars because it was going after its service. It was replacing someone that was driven by someone that was not driven, and he bought Otto. Did you know about Otto? Well, no one knew who Otto was until at a certain point in time they realized who was the Otto owner. It was $600 million. Who were the owners of Otto? Lewandowski. Well, the guy of the motorbike, of the little motorbike, to $640 million. And there you have Uber's president, Lewandowski, smiling broadly. Well, they smile broadly for a very short time. In all these stories, there is always a guy that sends the wrong mail. And so someone from a LiDAR company who had to send a mail to Uber.com sent it to Google.com. And he sent it to Google.com, a specification of LiDAR. The guy from Uber said, okay, this is our LiDAR. They go to the legal department that was well trained by then, and everything ended up in a terrible suit. The latest thing that Lewandowski had done, he had downloaded 25 gig of documents. They all go up to court. All those, I mentioned Larry Page, Chris Urmson, Sebastian Thrun, Lewandowski, they are all going up to court. It was phenomenal trouble. And Tesla filed a suit to Aurora because he had taken away autopilot. So they started with the self-driven car as something glorious, and it ended up in 2016 all in court. So the story wasn't developing very well, I'm afraid. And in fact, in between, the working team went on working, particularly at Google. And I think that at that time, it was 5 million miles driven by the self-driven car. Now, the trouble was that Google was desperate. It was trying to accelerate processes. And so we come to 2018, May 2018, something that no one would have liked that it happened. It was the first fatal accident of a self-driven car. So they accelerated things so much that they had a fatal accident. This was a lady who was on a bike. He wasn't riding the bike. He was going to cross the pedestrian walk, and the funny thing about her bike was that the wheels of the bike were covered, and so LiDAR didn't know what it was, but 6 seconds before it detected there was something wrong. 4 seconds before, in that strange object, it detected that there was a person, and at 0.3 second he said that he had to have an emergency brake. But the car didn't brake. Why didn't it brake? Because Uber had taken away that control, that command, the command of emergency brake, but because there had been many false positives. So what it did was that instead of braking, it would tell the driver that it had to brake. But Google had said that that was bad and dangerous, precisely because the person takes something 10 seconds, and in fact, the person who was driving at the time of the crash hadn't started braking. So that was a very bad idea. It was the straw that broke the camel's back. Lewandowski is probably in jail. The president of Uber is no longer the president, and Uber abandoned Otto, the self-driven car. it had to go back brutally. It has just announced that there was going to make a process with 500 million Toyota. It's completely different, and it's not using the same code as Lewandowski, but it delays everything that it had been working on. So that's what's happening. But as I said, electric cars is a very simple car, and then what happens is there are new types of vehicles coming out. Let me tell you something that happened to me. I go to San Diego every year to attend a conference. I went there last year, and I went this year, and when I went this year, to my surprise, it was full of these little things. These are single electric single bikes from a company called Bird. They're called scooters in English. And what's the story of these scooters? Well, it's not that you are the owner of the scooter, but they have their they have a QR code. You open it with an app, and they would charge you $1 to open the QR, and then 25 cents per hour, and they move along the on the pavement, and it's full of that on the pavements. Then the question is, how do you load it? I mean, they're electric. At a certain point in time, someone has to load it. Now, what happens is that they only work in daylight. It has no lights. So what happens is that the bird company pays people to hunt birds. That's what they say. So if you get hold of a bird and you take it home and you load it, it's cents, peanuts, and then you return it to the nest the following day, the following morning, you would be paid between $5 to $20. Well, if it's easy to hunt the bird, it's $5. If it's in a neighborhood that is a little bit risky, they would pay you $20. So what's happened is a new profession. It's bird hunters. So at 7 o'clock in the evening, there are people who go out to hunt birds, and this is what they look like. This is a guy who won, who hunted a bird, riding a bird. I couldn't count the number, but he had really done quite well, and he was happy, wasn't he? So, well, what I mean is that, look here, this is a business model on top of Uber. So when we say that the collaborative economy or interpersonal collaborative, someone was the owner of the car. Now, here the owner of the scooter is Bird, and the only thing he's getting is that someone charges it. And so he has it in over 30 cities in the US at a much lower cost if he had to make the whole scheme of charging. So these are new ways of organization. As I said at the beginning, this process led to what's happening right now. And when I say now, I mean in these days. It is imminent at present that Google will launch self-driven taxis in Phoenix, Arizona. Well, it forgot about that little egg. They decided that little egg wasn't a good idea. General Motors had presented something, Ford had presented something, but it wasn't Chrysler Fiat. Now, Google went up to Chrysler Fiat and proposed a business. And I'm going to buy 60,000 Chrysler Pacific. And Chrysler said, I'm delighted. And so what Google's got is 60,000 Pacific Chryslers in the U.S. There are 265,000 taxis. Now, Google already has 60,000. It's working in Phoenix, Arizona, but it's working without charging. And that's why I say now, I mean these days, they are going to start charging. Now, a very important detail here is that this self-driven car needs a perfect mapping of the city before. It's not that I bring down here this Pacific Chrysler of Google and I make it drive in Montevideo. It needs a perfect mapping, centimeter-wise. That's why the deployment is taking some time. But anyway, what I said, and that's why it was a very big bet in 2018. There is no other company in the world being close to developing self-driven cars as Google. Now we have Google's, and the most important accident that Google had was when it was driving at 2 miles per hour. Well, the Jaguar, the electric Jaguar, was also built, and it's going to be by 2020. But let me tell you the takeaways. What are the conclusions? What are my conclusions from the standpoint of technology and the standpoint of people? As regards technology, the first thing is that we are moving to a world of new types of vehicles. We can have new types. We've seen it with scooters, but we're going to have specific, specialized cars. Perhaps I'm going to have a car to drive along 18 de Julio only, along the main street only. But now we're probably going to have more specialized types of vehicles. The second thing is new kinds of organizations. What's happening with scooters is going to happen in other areas. Software starts becoming a collaboration mechanisms as never before. And the other one is that we were thinking of a new kind of programming. I mean, jokingly, when people were asking me what is GeneXus good for, I said it's to program missiles. And now I'm doubting about that. Well, I'm so interested in this paradigm that made me change an opinion. For some time, I had been saying that I didn't want my next car to have pistons. I wanted it to be electric. I don't care now if it has pistons. What I want is that my next car can be programmed by me. And now there are 3 models in Uruguay that I can buy them and I can program them. There's a little problem that I've got. They've come home and they told me that they were never going to get on board a car that I had programmed. But well, all right, you know, all entrepreneurs have some obstacles to overcome. So well, we're moving towards a new way, a new form of paradigm. We have to learn it. We have to dominate it, as Breogan said. Now, from the standpoint of people, what are the important topics there? Larry Page. Now, Larry Page is not a very well-known person. He's not charismatic. He has a problem in his vocal cords. He doesn't speak in public very often. But he drew 3 enormous rabbits from his hat. The first one was the Google one, then Android, and now self-driven cars. He's not the best known, not the most famous, but I respect him. And he knows how to hire lawyers. The second thing, what do we do with someone who is extremely intelligent but has no values? I think this is a clear story. We can't work with that person. And the third thing, difficult problems take time to be solved. They're not solved in a minute. Difficult problems are the interesting problems, are the ones that pay out. We have to focus on difficult problems. At GeneXus, is always focused on difficult problems. And the other conclusion that I can draw is that, you know, teams were functional, dysfunctional, there were wise decisions, there were bad decisions, there were fights, but at all times, there wasn't even faith, you know, you can't do this, it was said. But there was always a constant, something that they've always done. At all times, what they did and what they had was the power of doing. They were doing things. Thank you.
Muchas gracias, Nicolás.
you, Nicolas. Thank you all for coming to this GeneXus event. And now we have end of event cocktail. Please come next year to this to the next 29 GeneXus event. Thank you. Thank you very much for being here. Thank you for accompanying. Let's carry on.
Una cosa más, como es tradicional aquí en el escenario, les pedimos.
Please, those of you who are members of the company, come up front to take a family photograph, please.
Foto, por favor, gracias.